Yeah. So like there are two sides of us as we just delved into the side two. So there are two sides of scaling Filecoin with IPCs. There's the scaling of product operations, and by product operations I mean every operation that doesn't touch core consensus. Oh, I'll switch backs. Oh, does it work? Yeah, it works. That doesn't touch core product operations. And there's scaling consensus and incentive critical operations, because it's not only consensus, it's also incentives. Anytime you put incentive on something, especially large network incentive, there's willingness and eagerness to cheat, right? Because now I can win money based on it, so now I can cheat on it. So, but also why, like a lot of Juan's intro is great, for Filecoin itself, and especially for consensus side, we want low latency, extremely low latency in some cases, and I can delve deeper if there's interest why. But also increasing scale and increasing scale of things we can do, and making things generally faster. Like low latency will make things faster, but also just but because there's a POREP wise reasoning for it. Yeah, sorry. So sorry, that was my quick note. So like the goal is move storage operation into subnets and avoid harming the security in the process. And the second constraint either limits the scope of what we can move down into subnets or makes the problem much harder. The really hard question is, how do you create subnet which output feeds the consensus of the higher layer, right? Like the layer above, which is what we were just discussing, where the subnets feed the mainnet's consensus. So like some ideas, we don't have anything super concrete, right? But like for sure, cross-chain subnet proofs, so subnet information proofs, general information proofs, and then few ideas are aggregated and recursive proof of storage operations. So essentially, either specialized, so in this case, specialized proofs that prove state transitions of life of a sector, let's say, for example. And the subnet proves to the mainnet that it has this many sectors because all of those sectors in aggregate went through all the state transitions required to onboard the sector and keep it alive, and it didn't fold. The other option is something like ZKVMs for, so essentially you do a similar thing. Instead of you just program normal programming language, instead of having to think in terms of proofs, there are trade-offs between both of those approaches. Trade-offs that are getting better and better for ZKVM side, but yeah, sorry. And maybe no proofs. Maybe someone has some idea, like the idea of fraud proofs, right? But like at the end of the day, fraud proofs are still proofs. So the defaulting, like catching subnet cheating is a fraud proof, and it requires like 90% of the infrastructure that you require for ZKVM. Some things are easier, but a lot of infrastructure that's required for ZK solutions is required for fraud-proof solutions. And yeah, so let's discuss. I think we ended. Any questions regarding that so far? I'm surprised. So I will pose a question for myself right now. Why do we need very fast subnets for Filecoin itself? The primary reason we want them is fast. The shorter period of time we can have a challenge response loop for POREP, the faster we can make the unsealing. So if we give me a 100 millisecond subnet that I can rely on, in general, let's simplify. If you give me 100 millisecond subnet, I can give you a POREP that will have like 300 millisecond unsealing time, like estimate, instead of 30 minutes. Guy? Mike?
Yeah, about that. Don't forget the security trade-off. When you are going down to a subnet, then this subnet will be easier to harm its liveness.
Yeah.
So I'm not sure. Have to take that into account as well.
Yeah, 100%. Yeah, I haven't even thought about liveness itself, but yeah, 100% liveness is also a concern. Apart from even when you don't consider consensus side, yes.
Kuba, in Singapore only a couple of weeks ago, we started at this same place and eventually managed to decouple the block time of a subnet from the
With timestamping
polling time.
With timestamping
With
service.
a timestamping service, yeah.
My claim roughly would be that distributed timestamping service is just a subnet with a few components removed.
Well, it's not a blockchain. It doesn't have a sequencing guarantee. Which
Yes,
makes it a lot easier.
it's a blockchain with sequencing removed, which makes a difference.
And at most once removed.
Sorry?
And also no at most once, which is related.
Yeah.
It's much easier.
Yeah, it's easier.
It doesn't have to. The nodes don't have to reach any consensus in any time.
They do, and depends on your security. But we have session for timestamping service tomorrow. So.
Yep.
What's the bound you guys think you can get on proving time for ZK proofs? And like let's say 10 years out, it's at 1 second. Like, can it get to 100 milliseconds? And then kind of like on that question, do you need to rewrite FEM so it's ZK compatible?
So just to unpack, it depends what proof so you're asking about, right? Because if we're talking about storage proofs, then it also depends on the structure of POREP and everything, right? But like zero knowledge proofs are getting faster and faster every 6 months. Like I don't want to say double, but like plus 50% of speed every 6 months. It's incredible how close we are how much closer and closer we're getting to actually reasonable computation in zero knowledge. But a lot of the computation cost of zero knowledge, So the question about how small we can do it, like in the subnet itself, the subnet doesn't need to produce zero knowledge proofs every 100 milliseconds. It only needs to produce a summary proof, like if we use zero knowledge subnets, it only needs to produce a summary proof, like aggregation of or recursive proof to show its parent, to show that everything happened in that subnet correctly in case of zero knowledge subnets.
So maybe on the same topic of timestamping chain, like in a world in which we do have a timestamping subnet that's operating very, very quickly, probably not 100 milliseconds if it's global, but I don't know, very, very fast timestamping chain. Do we still need to be trusting subnet, like each different onboarding subnet, if they timestamp into a single timestamp chain, which does have, say, like, where you can identify when they've done their proofs?
So essentially, like we'll have to look at what's required to onboard a sector. And for example, one required operation is you lock up a collateral. You have to show that you locked up collateral. How you do it?
Gotcha.
I think my answer to your question is that it's critical for us to design this so that mainnet doesn't trust anything about the subnet except the verifiable computation. And so sort of a design criteria that it's not trusted. Yeah. And we should assume that the nodes in the subnet are colluding.
So that design also opens an amazing scope of designs. I think you mentioned this, Alex, in Singapore. Essentially, it could allow, like in the region, right? You could boot up a subnet that's sorry, I'm missing the word, that doesn't run consensus, that's authoritative, and still onboard storage into it. I don't know if we want that or not, but it opens that design space. Because if storage operations are zero knowledge verifiable, I don't need a consensus to verify that you did it correctly.
Yeah, like at the bottom level, layer 7 or whatever, you can just have like a computer. It's not running a blockchain. It's just doing the verifiable proof, and it's in one data center, and it's just doing storage operations in that one data center, and periodically checkpointing up the tree. And obviously, you don't trust that one node.
Two thoughts to that. On the earlier, now my brain. What was the last thing you mentioned?
Not trusting the subnet.
Yeah. So, by definition on the IPC model, because there's a subnet with more participants than a child, you should definitely not trust the children. Like, you should only trust the parent, not trust down. You should, rely on hard verifiability. I think, Molly, you were also talking about like a separate timestamp. If there was a separate tree that was timestamping, and you then had, at that point, it would boil into the guarantees of the timestamp and whether or not those are like reasonable for mainnet. and this is where Alex is saying for the mainnet, like just let's remember that like mainnets have to be super careful about what they trust. So like currently Filecoin trusts DRAND and it relies on DRAND working, but other than that doesn't rely on anything else other than itself. And so in what Molly described, it would add the dependence to another timestamp thing in the same model as DRAND. And so we should just be very careful about adding those requirements. And then on the other part that Adrian was talking about, like the very low level, you just have a computer running a thing. Yeah, exactly. I think like that's what the model should give you. At that point, like the blockchain part, like to make it part of a subnet in a sense, you can have a subnet of one. What really matters is like between a checkpoint and another checkpoint, what are the state transitions that you're going to report up, and what does that look like to the world? And we should be, as requirements for IPC, like we should keep the requirements for what means a subnet like as low as we possibly can, and figure out like what if anything, like there are things that some common subnets will want, but we should kind of like be very clear about not accidentally overburdening what a subnet means. And so maybe think of like groups of feature sets that subnets of different types might choose to support. So for example, like do you need to make all of the state transitions available such that they can be viewed in a state explorer of some sort? Like maybe, but you don't need it for all subnets, right? It's certainly not the Anor's computer at the very bottom. Like you just need like maybe just like the input and the output or something like that.
Do subnets by default or by design mandatory need to have their own validators, or can they use other ones from their parents, for example?
I would punt that question to IPC team.
Yeah, the validators are segregated per subnet. I mean, it can be the same machines, but it is an independent process. I mean, it's an independent validator. There have been discussions of eigenlayer style reusing stake, but that's not part of the roadmap right now.
But like your validator can be super, super lightweight. It can be a process running on the local machine, which is being your single storage provider, onboarding its data. Like it doesn't need to be a heavy process, and it could be a single machine that's running those set of processes. Correct?
Okay.
Yeah.
So being light, so it's not seen as a difficulty to, let's say I want to deploy my own subnet, but I don't find any validators because I don't find ways to incentivize them to join my testnet, or how can I assure that I have enough validators?
So for Juan, you want to take this one?
Yeah, so some of the model that we're thinking about is like, it'll be useful and valuable to have pools of validators that are just looking around to see what subnet is it economically viable for them to join and help support. And the IPC model likely will have that in a lot of IPC trees. For Filecoin specifically, there'll be a question of like which subnets require storage in terms of power and which ones are just like, consensus validator, like in any other chain, because that'll change the requirements of like who can join them. But yeah, I think like the point that you're making is really key, which is, hey, fanning out and so on is really neat, but you have to like make it super easy to recruit parties to help join your subnet and help you run it, because otherwise like it'll go away.
Well, the thing that Molly, you were saying around that it can be like a very lightweight processes that can be like running literally like tons of them over single virtual machines. That's actually something that we saw over our experiments as well. That's very true. However, the question here that we still didn't have a chance to test, and that is where my question is coming from. If the chain is going to be growing in terms of like transactions and all that, and like, might it be there a chance that it's going to be like growing in the resource intensive and it might like start competing over them?
That's why it's recursive. Like you start stepping layer lower. You essentially create, instead of everyone going to the L3 and creating the subnet in L3, you create 2 L4s that everyone is encouraged to join.
Yeah, that's yeah. I will walk to you, guy. But yeah, but you know, even then, like fast chains do tend to be very storage intensive, but they also can be garbage collected. It all depends on what you want in terms of persistence of data. But go ahead.
And
The key word in what Kuba said is recursion. Somehow the blockchain world forgot about recursion, and we're bringing it back.
There is one thing about the trust model that we are using, and when we are saying that that a child trusts its parent, that means that a child validator needs to have a point at the parent that it trusts, a full node that it trusts. So if you use an RPC, I don't know, maybe it might be better if you also have a validator or some kind of full node at the parent, because that is part of the trust model. When you are trusting your parent, that means that you also need to trust the full node that you have at a parent.
So trust but verify your parents?
Hopefully, if this, you're in the realization of this model, it gets a lot easier to run a parent node, particularly a Filecoin mainnet mode, because the like, I don't know, 50 terabytes of state or whatever that it currently has is all gone because it's all distributed among all the subnets. So you've just got to verify. All it's doing is verifying ZK proofs, and basically doesn't have any state.
Yeah, but sorry. But about verifying the CKs, like, I mean, I know you mentioned that they're getting faster and faster at incredible speeds, but last time I checked, they're still pretty far from 1 second or 100 milliseconds.
Verifying or producing?
No, not for verifying, for producing.
Yeah, but it's fine because you have you can, for recursive proofs, you can produce them in parallel. You don't have to produce them sequentially. A lot of the computations, you can do in parallel instead of having to do it sequentially. And on the other side, like, it's only, you have to produce for zero knowledge subnets, yes, you have to produce a proof of the whole computation. But one, we can reduce the amount of computation there is because we can move a lot of things we can create clear separation of what's consensus critical and what's not, at least for Filecoin, and only perform operations which are consensus critical in the zero knowledge version of the subnet essentially. And every other information about sector, about what data it's stored in it, and so on, can be performed outside of the zero knowledge.
Yeah, and so is there no latency constraint in this model at the parent to receive this ZK?
So the parent has to receive the ZK at the point, like at the checkpointing point, right? So to validate the data checkpoint, the parent would require the proof, but also there's like timestamping concerns, which is where the discussions of timestamping services and the timestamping chains come in.
I expect there will be some deadline for a storage power carrying subnet to checkpoint into its parent before the parent's unwilling, is going to be, we're going to hard code in that it's unwilling to grant it power anymore until it checks in. And so if you don't check in, by the end of the week, power's cut until you check in again, something like that.
Sorry for dumb question, but getting back to L3, L4, all that recursive stuff, you were saying like, okay, it's going to be like, yes, if L3 is going to be too big, we're going to be like having multiple L4 and all that. But is it going to be like the automatic process, or it's still like the manual stuff that you need to be done?
I don't know. I don't work on IPC, so.
Yeah, well, that's the problem that comes to my mind. I mean, like if it's still a manual work, it's. The separation, the L3 into like more simple L4s and all that, like it's can be done automatically. I think it's like.
Yeah, so we're trying to get to the point where this is programmatic, and you should be able to automatically generate those children. The ones that I showed are most likely going to be long running, because those that I showed are meant to be like large regional things, but a lot of subtrees can.
Yeah, sorry, let me just, there's a big discussion between, with respect to how automated this should be and how integrated like the deployment and DevOps side should be with the IPC stack. I firmly believe that it should be on the IPC application side, not part of the protocol. But I mean, it can definitely be automated. I mean,
although there are like security considerations for it being automatic, because essentially, let's say I set up an application in your L3 and I'm happy with the consensus security, but then you split that L3 into two L4s and throw me into one of those L4s, I might not be happy anymore about security. Molly.
And I imagine you'd probably want to do that on like more, like that'd be a subnet level decision of like, do we want to set a level at which we auto recurse, or do we want to, you know, like that's a policy decision that should be in the hands of that subnet. It should absolutely be an option to be like, great, we're going to auto subdivide at this layer. And it might also be a great, we're not going to auto subdivide and we're going to have an on-chain like, you know, vote or upgrade to do that. Or it might be, hey, we just never want to do that, and like our neighbors will subdivide and we won't, or something. And it just depends on the policy at a subnet level, I would imagine.
Yeah, I think right now we're mixing a lot of like the IPC model questions and then Filecoin specific questions. I think and then even within Filecoin, Filecoin questions for the main subnets that are, you know, storage carrying and so on from other applications. And I think like a lot of these things are like, when we're talking about capabilities, they're more on the IPC side of just enabling a lot of different things. Now, Filecoin might want to create restrictions and have policies that are going to be followed by, have a set of trees that behave a certain way. So there are conventions for how it's supposed to happen, right? So if we're trying to emulate geographical regions in a specific spot with a data center, then we're going to have a policy there about like which parties can join and which ones can't. Do they need to pass a proof of location or not? Or how fast the block time is and so on. And that just becomes configuration parameters on the tree.
Yeah. Once IPC is deployed or is on mainnet, what are the expectations for the host node in terms of how much will they increase? Like we have 40 terabytes today. Do we need to get ready for 100 or not necessarily incrementally like that?
So IPC, the contract should not really affect like normal Falcon nodes. If those Falcon nodes become validator nodes for like layer 2s, layer 3s, then like their footprint will increase because they have to validate those lower layers. But the key point is that subnets allow you to create more layers without additional load, significant load for L0 or 1 or whatever we call it. Because essentially you get O1 operations required at the top layer for how many operations you want in the lower layers.
I presume you're asking the question specifically for when IPC is deployed on, not the first deployment of IPC on Filecoin mainnet, but when IPC is creating subnets that include storage load, storage proofs in Filecoin. And I think that guess is that we might actually see a decrease in the amount of load on mainnet, so less state required on mainnet because more of that state would be being pushed into the subnets, and then checkpointed into the mainnet, which is a much smaller amount of bandwidth that host mainnet nodes would need to.
As Einart was saying, hopefully we're going to move a ton of the state that is currently in mainnet into the subnets, and so the mainnet will get very light.
Well, I mean, like, shame that Peter is not here, because I would love to hear his input on all that. We were discussing with him just yesterday about all the situation, right? About the growing of the archival nodes and all that. I mean, like, I think, like, given how the archival nodes are built right now, even if we move the majority of the load from the mainnet to the subnets, and then on the mainnet is going to be less, the chain state, due to like synthetic stuff that he was explaining yesterday, will still going to be growing at the very same speed.
No, I mean, this gets back to what Andrew was saying. Like we should be able to take all of that state, store it as Filecoin deals, and then pull it back out later.
But also, like the archival state size won't ever decrease because that's a history that happened, and it needs to be. But the growth of if we achieve this model of IPC subnets, storage onboarded in IPC, then majority of the mainnet chain will summarize to validating subnets, validating zero proofs about storage.
Yeah, I don't. So I'll be like a contrarian person here, I don't think you need archival nodes at all. I think you just archive the state into Filecoin as storage, and then you pull it back out later. And you only need to maintain the chain required for consensus. If you want to be like extra safe, you keep around like a week. But I don't think you need. We've evolved way far away from like the original Bitcoin model of like you need the entire chain. We have checkpoints. We have storage platforms. We have all kinds of things that weren't around before.
We don't use UTXOs.
Well, you don't need it for the majority of cases. It's just like some specific things that are still there.
No, but like for example, if you find an archival node and it tells you that the real chain is a different chain, but the rest of the network just follows a different head, good luck trying to convince the network to follow your other chain, right? Like,
Well, I think what you might see, which I don't think we've seen yet, but would be a really, really interesting thing to see is, for example, like exchanges, Coinbase, other folks, like booting archival nodes from snapshots on demand would be really interesting. If you have the full archival history stored in Filecoin or something, and you can spin up an archival node quickly, that would be awesome. But actually what most people do is they sync an archival node from Genesis, validating
or just
each-
build an implementation that just pulls it out of Filecoin storage using like Magic's Ribs or something. Ribs is a block store, sorry. Not Magic's actual physical Ribs.
I don't think like somebody is really thinking the archival nodes from scratch right now. It would literally take, I mean, half a year. I don't know.
No, not really.
But yeah, that's what I mean. Like you could just pull it out of, you could have a Filecoin node implementation that just uses as its block store the stuff that's on Filecoin deals. And so when it like tries to search that part of the history, it will like pull the deal out and get it.
Yeah, I have a totally different question, and I know that you're talking about like the Filecoin sort of implementation of IPC subnets with storage embedded in them, but then I got this kind of question trying to map it to the IPC sort of like SDK or whatever you'd imagine that developers would use. So I can see like, all right, so the mainnet isn't going to care who spins up a subnet because it's incentivized based on just the proofs. Like it doesn't care. So then my question is IPC being built in such a way that if I create a subnet, my subnet will automatically support subnets on it out of the box? Like that's just, there's a method call that anybody can call to create subnets on my subnet? So
It's a configuration. It should be a configuration parameter that you as the runner of the subnet should decide that.
at like
It's
sort
just
of-
an actor. So it's an actor that's on chain, and you decide whether or not you want that actor to be there or not.
at sort of like boot up time, and then
Yeah.
everybody who joins that subnet sort of agrees on it, and there's
Yeah.
some
And
consensus process to flip the switch if it ever needs to change.
Well,
or-
there'll be some subnets that will restrict the actors that you can put on it. Like some subnets will just not allow arbitrary smart contracts to be added. So if you disallow the actor to be added in the beginning and you don't allow other actors to be added, then nobody can add it.
But I believe there is a Solidity-based IPC node that if you, for example, have a subnet with FEM, which enables
EVM.
user...
You don't even need full FEM. You just need EVM, I think. Yes.
Yeah, EVM or FEM, but FEM is what comes by default in any new IPC subnet you create. And if you, in that configuration, enable any user to deploy any smart contract on FEM, they could deploy the IPC like Solidity actor to FEVM.
Yeah, I mean, in order to deploy a subnet, the only thing you need is the ability to deploy a subnet actor on the parent and the existing gateway actor, or the ability to deploy it yourself. So provided that you can deploy actors, you can create a subnet. Obviously, yeah, if you restrict the creation of actors and then you restrict the actors that you have running to permission the creation of subnets, I mean, that can be done. It's an option, but then like you need to restrict general actors, otherwise.
Yeah, this gets into like IPC applications, but like there are some applications that just want to run a special purpose network that don't want they don't want like your random other smart contracts in here, like throw that elsewhere, and so they'll just want to restrict the actors that can be added, right? So like we're designing, I don't know if
Like you could have FEM without FEVM and you can only have like whatever actors you choose to deploy on the network using whatever consensus process you have, and not,
No, but you could have
random
FEVM
openness.
in there, but just not allow other actors to be added. Like you
Why
could like
not?
restrict the programs. Think of it as like creating a container image with like the things you want in there, and then like not anything else.
Yeah, that's actually how you guys were playing around with with the tableland on Fenderman. Yeah.
Yeah, I just didn't know if when you kind of go to production, whether that switch is on, off by default, toggleable by people.
Yeah, it's on by default, but yeah.
It's essentially you create on your own consensus in the subnet. If you want to disallow it, there's nothing anyone can do to prevent you from disallowing the consensus participant.
There should probably be state on the state tree. The configuration of the subnet and what it should allow should probably be viewable from the state tree, so that you can use a blockchain explorer to understand it.
No, like I was gonna say that I was thinking about what parameters we track, because in Fenderman now we have that. So there's a bunch of state parameters that we put in the state in Genesis, and it evolves.
That whole configuration, if it's for the network, it should just make its way into the state tree.
It is part of the state tree already.
All right, sweet.
So, but like I don't know if we're exposing. I don't know what we're tracking. I can't remember, and I don't know if we're exposing it for external. Like you have to inspect the state.
This seems like stuff that should go into the system actor or something.
We discussed in the yellow runtime thing pushing the state tree into the system actor, so that
I would say at that
all of the state, all of the state tree.
the state tree as part of the system actor, because then you have like you can even like upgrades of the state tree are immediate. Ish, because like
just whenever you're modeling that, also factor in that when somebody's gonna inspect all of this state across the entire IPC tree or the forest of IPC trees, it's just IPLD, right? So you're just gonna navigate a bunch of IPLD data structures, and so you want it to kind of like make intuitive sense as you're walking down the trees, and you're crossing the boundaries of a chain, to find like the right account and so on.
So we built something that it's really cool, that we call the IPLD resolver, so that we can make, right now it's just like you can make calls to a specific subnet for a CAD, and you inspect the state tree using bitswap, like you bitswap or fallback to point, and you get a CAD for a specific subnet. But having it in a system actor would be even better.
Yeah,
Like, then we all have the same model.
Yeah, all I'm saying is like, think of like the types, and then think of like, once you have a ton of these trees, like very large trees with like hundreds or thousands of subnets, and then you're trying to like imagine navigating this mess, you want like, think of like manually walking down the tree and how you want the abstractions to look like, so that it's intuitive and reasonable, like you would normally navigate down a JSON tree. Right, so like when you think of like some random object in JSON, that's usually sometimes embedded in another object, embedded in another object, embedded in another object. So all of computer science is just trees and trees and trees and trees, and you want to be like navigating. You want to make it intuitive to like navigate down those trees and cross boundaries and so on.
Just a call out for the parent chain. Like if you include the state CID in the parent chain, right, and it's a CID of full state, it will need to be marked as not followable from the parent state.
We faced a bunch of issues with identity CID and stuff.
Yeah, so I wonder if this would help. Of course, you can do zero knowledge execution in subnets, and that's clear. It might be challenging to do. So what we might do is we keep the validators in the classical sense, so those that construct the blocks only in the region. But then we replicate for data availability and for fraud, later for fraud proofs across all SPs.
Yeah.
You see what I mean?
Yeah, I see what you mean. Yeah. And like it's the decision matrix between fraud proofs and zero knowledge, because both of them have their pluses and negatives, and the industry still haven't settled on one, and so like it might make sense for this to be fraud proofs, but also like as we discussed previously, like fraud proofs are almost a stepping stone towards zero knowledge. Like they are way easier but almost a stepping stone.
Don't get me wrong. If you can get this in zero knowledge, we do it. I'm just trying to understand how can we do it more quickly with something that we can do today, while boosting the security and not relying, like not reducing the security to rely only on regional validators for security.
For consensus power, like for sure we cannot deploy a version with just regional validators. Like that's my claim.
I agree.
Yeah, I mean, by the way, we're half an hour into the happy hour, which is totally fine with me.
Wait,
but yeah.
This is the happy hour.
But yeah.
We still have half an hour of your closing.
I mean, like, still waiting for your final speech.
Yeah,
It's like scheduled for half an hour ago.
Exactly. It's all right.
Any other big questions that people have about like Filecoin and IPC and so on that should turn into requirements for the IPC software? So we've discussed a bunch of interesting things, both in the model and in the software. Thankfully, it's all recorded. Yeah.
Yeah, I just keep going back and thinking about like an approach to implementing things in the IPC, and there's in this like Filecoin use case of moving storage into subnets, and then there's like subnets for applications or whatever. There's like a mismatch in my head almost that like if you ran to production with subnets with the parent chain being mainnet, but then storage starts moving off, fanning out into all these subnets, you're in the wrong place.
Well, no, because I mean, at the end of the day, you can interact with any computer you want to, right? Like when you interact with storage and you store something or retrieve it, you're never really interacting with the chain as much. Sometimes you are, like when you make I guess you are when you're making a deal and so on. But a lot of that is point-to-point interactions. And so just the consensus tree is its own separate thing that just boots up the network. You can always go talk to any storage provider and ask it to store your stuff. It just might be homed somewhere else. So think of it kind of like you would normally today. Think about like homing some stuff in an S3 bucket. Like your S3 bucket is probably homed in a particular region. I guess that might not be the best example because S3 regions are like really notoriously hard to like reason about and move.
Yeah, but this is what I'm trying to reason about is like I think some of the coolest use cases of IPC come from Filecoin, from the idea that like state is addressable across a giant network of storage, and I can use that state to rehydrate my VM or shut down my VM and know that it exists somewhere. And so logically, in like the Filecoin use of IPC, I see like, okay, there's some subnets that now have storage. Shouldn't I think about having subnets to them where I'm rolling up things to them so that they can store it, you know?
Yeah. I mean,
instead of going like hopping way through the tree and all of that. So it's kind of like a midterm question of like, where's the right place to be deploying applications so you have an efficient network of applications using storage.
I think the efficiency for, like we have to get the efficiency of calling across these subnets really good. Meaning it should normally not be congested and it should be pretty fast to call between them. So like where you're getting at is like with this tree, if it expands a lot and there's a lot going on, it could get difficult to like call across these. And so we have to be careful about reasoning about that and rehoming things. This is the kind of stuff that like we'll want to make operationally better the way that migrating VMs in the cloud is operationally easy, right? Like you always have your EC2 VM always exists, and like you don't have to worry about what physical computer it's in.
Yeah, but that's actually pointing at the same problem because like if you go back to one of your first slides with the hypothetical regionality of Filecoin, if you today in the cloud world go and build your application, you want to co-locate what region you're doing storage, what region you're putting your database, what region you're putting your API. I imagine the exact same stuff would flush out here.
Yeah, totally. I think that's where like I personally see applications spanning the regions, and so you would kind of like maybe register your application once at the very top in the mainnet, and then you would have instances in the different regions that matter to you. A very concrete example of this is like a compute over data network where you want to run like a ton of computation over some state, and you're going to be like storing it and retrieving it and running functions and so on. And you want like very low latencies in that, like you want sub-second latencies there. And so you don't have any time to like go out to some other random data center somewhere else. And so yeah, at that point you really want to co-locate stuff. So yeah, I think we'll figure out like how that evolves and whether or not kind of like the apps have their own trees or apps exist in the same shared tree question. That we'll kind of like we're gonna have to experiment with both models and see which ones like pan out for what kinds of applications. I think that it'll be a lot of like store data, compute over it, index it, like update it, and so on. That will want to happen very co-located. Like when you think about a normal application today, like you submit a tweet with some images into a Twitter process. And then it like first receives the thing and stores it, and then like starts indexing in parallel we'll index the information in some database, and then we'll take the images that you posted and like we'll check for abuse or whatever, or like, you know, downscale them to different sizes or whatever. And then like we'll also separately do object recognition and then tag things and put them into news feeds. And like you'll have like all of these different processes that spawn out. A lot of that might happen might be orchestrated by the same subnet, or it might span a few subnets that are co-located or close to each other. But you want all of that to happen in like seconds, not like, you know, wait minutes for the whole, or hours for the world to like update. So I don't know. I think we'll figure it out as like application scale starts pressure testing a lot of this. And I think we'll have to like, probably the most important quality is that we experiment a lot with this and then figure out what are the patterns that are working well and kind of like where to lean into.